All right, so we are going live. Finally, I had some serious technical difficulties here. Um, Not sure what happened, but I think we're live now. I just don't know where. Somewhere in Facebook land, I suppose. So, hi, world. I'm Irene Pease, and I'm here with the Amateur Astronomers Association of New York. Um, Welcome to your Thursday evening dose of astronomy. We are going to be taking a tour, looking at some of the gassiness in the universe, which should be really exciting. And we're going to be using a couple of the same programs we usually use to do that. We'll be using OpenSpace, which you can find at openspaceproject.com. Download it for free. It's freeware. Recommend a good graphics card to do that. Um, but, uh, but yeah, you should be able to access it there. And then also we'll be using Stellarium, which you can find at stellarium.org. And can download that, put it on your computer, desktop, all your devices and things. Yeah, so we'll be using both of those tonight. And sorry, I haven't found my comments yet, but I'll look for those as we go. Sorry for the delay, but welcome everyone. So tonight, as we like to, we'll be starting with some Stellarium. So I'll click over there. And I was really excited for this because, oh look, you know that tree that's usually like blocking our western horizon? It moved. So it's further southwest. So I'm pretty excited about that. So here we are looking at now, which of course is still really bright. So we'll move to a little bit later, about an hour from now, a little after 9 o'clock tonight. And if we look at the challenge from last week, I've been challenging folks to look up and see the spot. I know for a couple weeks we've focused up here near Cygnus, and we were looking at the Veil Nebula, which was kind of on one side of Cygnus, and we looked at that patch in the sky that has lots of exoplanets. Actually, most patches of the sky have lots of exoplanets, but there's this one patch over here that we looked really hard, and so we found more there. But if we looked just as hard elsewhere, we'd probably find just as many elsewhere. So, so that's been a a challenge, asking folks to look for that. And some other things that you might see up there this coming week, just kind of scanning the sky. That's going to be your challenge for the week, is scanning the sky along Cygnus and then down towards the south with a pair of binoculars. So either go out to a really dark site and look along the Milky Way for fuzzy spots, or if you're in a not super dark site, you can look with binoculars and see what you can see along there. So if you kind of scan down, you notice the Milky Way is super bright along here. And with all the gloriousness of Stellarium, we can actually zoom in. And we've talked about some of these things. We've talked about some of the star clusters, these open clusters that are groups of young stars that are down there. Those will look like kind of fuzzy patches to the naked eye, maybe a little bit fuzzy, or maybe see some individual stars with binoculars. And then also with binoculars or a small telescope, we have these colorful fuzzy spots. Ooh, so you won't really see the color with binoculars or a telescope, but you'll know that it's there, which is part of the excitement. So we have this blob. That's M20, the Lagoon Nebula, and then we have another blob. And by blob, I mean huge cloud of gas in space, because that's our topic for this week, is huge clouds of gas in space, just space gas, which is exciting. We call them nebulae because they look nebulous or, you know, fuzzy. So this is a really nice one. The Trifid has like some pink and some blue. And just a heads up, most of the gas that we're going to be talking about is hydrogen gas, because as we'll see, most of the universe, most of the atoms in the universe, I should say, are hydrogen atoms. Here's another great one. This one's really kind of neat. In a telescope, it actually kind of looks like a swan. It's called the Swan Nebula or the Omega Nebula, and you have to use a little imagination. And maybe it's more of like a duck than a swan, but like this bright part shows up really nicely in medium-sized telescopes, and it looks like a duck or a swan floating on water. So like this is your water line. Okay, a lot of imagination, or maybe some wine. Anyway, so moving on. And then you have these others, like this is a really famous one, the Eagle Nebula, which there's different ways you can see an eagle in there, and I'll let you figure that out in all your spare time. So some really pretty fuzzy spots to look for. So these are huge clouds of gas where, where stars are being born mostly. If we turn on our kind of our symbols, right? So we've talked about the dotted circles, those are our open clusters, but we're seeing that some of the blobs that we just talked about, there are these the green boxes. So those are nebulae, those are big clouds of gas, and they also have like kind of dotted circles associated with them. So those are stars that would have formed in those clouds of gas. They're associated with those objects. So that's your challenge. Look along the Milky Way, see what blobs you can see. And if you say, well, I live in New York and it's really bright and I don't have binoculars, then I have a different challenge for you. So I came prepared except for the tech stuff tonight. So if I remember how to do this, we're going to turn off all the labels. So it's going to be a big fun surprise. And we're going to turn up the light pollution. That's more like New York. Okay. So, and we're going to spin around. So blindfold yourself and spin around. Oh wait, and I was going to turn off the directions too. Okay, this is going to be really fun. So it's like pin the tail on the donkey kind of thing, except like you're just spinning around the sky and there's not supposed to be a label there. I missed a label. Let's see if I can get all the star labels off. There we go. That's better. Okay, so there's a tree, there's a bench, there's a lake, there's a tree, there's a bench, and we're going to look up and find the bright thing. Okay, where's the bright thing in the sky? That's it. Okay, so that's Jupiter. So your second challenge, if you don't have binoculars, if you don't have a dark sky, go outside and find the brightest thing. And if you happen to know which way is south, it's going to be towards the south. The bright thing is Jupiter. And then the brightest thing to the left of it, that's not too far to the left of it, is Saturn. So nothing else, go out and check out the planets. And maybe make a note of how far apart they are. They're going to be getting closer and closer together for the remainder of this year. And then we're going to have a really special, exciting thing. I think in December, they're going to be like right smack dab on top of each other. From our point of view, not actually in space. They're still going to be really far apart out in space. So yeah, so that's your challenge for the week. Look for nebulae and or the gas giants. So see, they'll still count as gas. See what I did there? So let's go ahead and switch over to our open space. Get out into space. Zoom. And we're in space. Okay, much better. So roomy out here. So in open space, I actually can do a lot of cool things. One of the things I can do is turn off the Earth. I don't actually have to, but just because I can, I think we will just this time around. Earth and its atmosphere. Goodbye, Earth. Goodbye, atmosphere. And we're going to turn on something else. Well, actually, let's just kind of scan along. Let me find the Milky Way. There's part of the Milky Way. And so we'll try and kind of turn the Milky Way so it goes lengthwise along our field. So the stuff that we're looking for, as usual, is going to be mostly found in the plane of the Milky Way, because, you know, that's the plane of the Milky Way. That's where there's just a lot more stuff. So if I kind of pan along here, we'll notice that some parts of the Milky Way are a little bit brighter. Some parts are, oops, let me move that up a little bit. Whoops. Does this thing. See, I thought I was being clever and trying to find the comments while this was playing. Like, I'm going to put this on autopilot. And here, we'll go the other way. and see if I can get to us. Not quite. Okay. So we're so yeah, so there goes the brightest part of the Milky Way. We were just looking, where I was just showing you some of those blobs, and then coming up along here, actually, oops, I come back to where we just were. There's that other part of the Milky Way. It's going up by Cygnus. So I actually want to take a look up there a little bit. So up here we have this is Deneb and Vega and Altair. So we have the summer triangle up there. So remember, this is Cygnus, the swan, in here. So Deneb is the tail. And you can already start to see, like, there's some, I don't know if you can tell, there's a little bit of red, some red stuff in here. But I'm going to go ahead and turn on an all-sky survey that's, wow, it's kind of red. So this is our hydrogen alpha all-sky survey, and there have been a couple of surveys. As I was reading about these, I came across a really fun one. I actually lived in Wisconsin for a while, and they at the University of Wisconsin, they have a pretty nice astronomy program. But this is the Wisconsin Hydrogen Alpha Mapper. That's the survey, the Wisconsin Hydrogen Alpha Mapper. So put that all together, and yes, you get WHAM. So this is the WHAM. Well, this might not be WHAM, but they have a survey that looks a lot like this. If you kind of scan along the Milky Way, there's all this stuff. So first of all, hydrogen alpha, remember I said most of the atoms in the universe are hydrogen, and so hydrogen puts out a couple of lines, specific frequencies or specific wavelengths. Those are going to be related. And one of the big ones is this alpha line. And when I teach my astronomy classes, I drill into their brains. It's 656 nanometers, so they all know that. So there's some huge features. This is, again, all along the plane. You might not recognize this, this relatively familiar part of the sky. Let's see if I can bring up a little hint. Yeah, that's Orion. So there's actually a whole mess of this gas, this hydrogen gas, that forms what we call the Barnard Loop over by Orion. And then there's like a big ball up here. So there's a lot of these really interesting features. And actually, I just want to try to zoom out a little bit real quick, so you can get maybe just a wider view here, slightly wider view of, oh, wow, all these amazing features. So a lot of them are kind of, like these large ball shapes, some more so than others, but just a lot of relatively thin hydrogen gas. So like the nebulas that we were looking at before in Stellarium, those are like tens or maybe 100 or so light years across. These are a bit larger. Like these are several hundred light years across in some cases, like some of these loops. And actually there is a huge one around Cygnus. Cygnus is a very busy area of the sky as far as this hydrogen alpha and nebulae in general are concerned. So some less busy parts of the Milky Way, and then definitely some busier parts of the Milky Way with all that gas. So that's those aren't necessarily nebula that we'll be able to see in like amateur telescopes, because if you're looking at these, you're thinking, wow, those are huge, right? So if I look with my telescope, I'm only going to see like a teeny tiny piece of sky. I'm not going to see like that whole loop that was by Orion, or even like this whole ball here. They're very puffy, so very large, very extended. But we do have a data set that shows, of course we have all these fun data sets. We do have a data set that shows more of the nebulae that we were looking at in Stellarium. So let me pull those up. Those are called our H2 regions, and they're these big blue hexagons. So obviously they don't look like big blue hexagons. I already showed you they look like mostly kind of pinky um, fuzzy spots. But these are markers. These are where they are. And so you can see those are, along the plane of the Milky Way. Some kind of interesting features in this data set. One, you see that there's a whole bunch of them over here. So again, that's not the center of our galaxy where we're looking at the nebulae in Stellarium, but this is actually over by Cygnus. So again, Cygnus is pretty busy, and I think there was actually like a survey that was looking over here. Don't quote me on that, but that's kind of a guess. When you see a huge clustering like that, it's probably because there was a survey that was looking in that particular region of the sky. But let's just go ahead and I'm going to turn off our H alpha, and we're going to kind of pull away from the Earth, and, well, which we can't see anyway. Pull away from the Earth, pull away from the sun, pull away out. There goes the sun out into the Milky Way, and we can see this distribution across our awesome galaxy. So kind of looking up here, an interesting feature that I noticed in the data set, maybe you can see it. So again, like even if we look at this data set, looking along the plane of the galaxy, yep, they're mostly in the plane. They're not so much off the plane in I'd say the halo, as it were. But let me just turn on. I'm going to turn on a marker. I like to use the constellation lines as kind of a marker of where we are, right? Because so those are the brightest stars that make up the star patterns, the constellations that we maybe recognize, maybe don't in the night sky. But if we kind of look towards the center of the galaxy, I think it's kind of interesting to see this kind of like V shape. There's this gaping V in our data set, right? So if you kind of draw a line off in this direction and then a line off in this direction, so obviously it's really hard to see through all the density of gas and stars and dust and stuff near the center of the galaxy. So that's blocking our view of the far side. So we're not able to see through it, not able to map out these H2 regions on the far side. And even on the near side between us and the center, there aren't very many that we've mapped. So I don't know if that's just a coincidence or if that's actually part of the issues with viewing. So yeah, so these are mostly star-forming regions. So H2, that's what astronomers call this stuff, H2. If you're a chemist, you might call it H+, so it's ionized hydrogen. So H1 for astronomers means neutral hydrogen, and then H2 means that it's ionized, so who knew? So yeah, so I'm not sure why we're not seeing stuff along in here. I don't know if it's just the background, or, I mean, in some other directions there's kind of gaping holes where there isn't, where we don't see a lot of the blue dots. So maybe that's just a pattern that my eye picked out and it's slightly artificial, or maybe there is an issue. So I'm not positive about that part that Chris is asking about. But yeah, so we have, so we looked at the hydrogen alpha. We're looking at these star-forming regions, and again, these will be, about 100 or so light years across, and these are these huge pockets of gas that will collapse to form stars. And so that's why you had those star clusters associated with some of the nebulae that we saw in Stellarium. The gas in here, though, when we're talking about these nebula and how much gas there is and all this stuff, in these H2 regions, it's not like gas like we have in our atmosphere. So I looked up numbers. I don't like to throw out a lot of numbers, but in our atmosphere on Earth, it's about 7 trillion atoms or molecules per cubic centimeter, right? So that's a lot, right? That's why you can breathe and you're not hopefully gasping with or without a mask. But these H2 regions, they have more like 1,000,000 particles per cubic centimeter. So from 1,000,000 to a trillion, we throw these like million, billion, trillion. A trillion is 1,000,000 million, right? So our atmosphere is 1,000,000 times more dense, essentially, than, than these gas regions in space. So not very dense, right? But there's enough stuff there, and it's extensive enough that that we can actually see these. So those are some of the denser regions of gas. But I just wanted to point out, because I was shocked when I learned this, a lot of the gas is actually between the stars. So we have more gas that's between the stars. And if you were to guess, like if I were to guess, like where's most of the gas in the universe? Well, like clearly, you know, it's in these nebulae that are in these galaxies. And I would have been wrong. So it turns out that most of the gas in the universe is out between the galaxies, out in this crazy, wacky, intergalactic medium. So partly an excuse just to take us out into the galaxies. But yeah, I felt kind of hungry earlier, so I decided, is that it? Yeah, there's a pie chart. So this is a beautiful pie chart. This is from NASA. Thank you, NASA. And various charts might have slightly different numbers, but you get the general idea. So of all the stuff, the mass energy in the universe, most of it is dark energy, which basically means we don't know what that is. Okay, so don't ask me because we don't know. I don't know. No one knows. We think it's there. I'm not gonna, that's a whole other show. And then, so that's like 2/3 of it, or between 2/3 and 3/4. It's a lot, right? 68% on this pie chart. Dark matter, which seems to have mass, and we think we know that that exists, and we think we're getting closer to finding it, but then I feel like every time we think we're closer, we don't. So that's not, you know, kind of annoying. But yeah, so that's other stuff that we can't really figure out. We don't really know what that is. Some ideas, some theories, but we kind of still don't know. But we know a little bit more about that than we think we know about this dark energy stuff. That's still just the biggest question mark. And then there's what they call visible matter. I call atoms. Some other charts call it baryonic matter. So, and most of that, that's 5%, right? So that's all the stars, all the gas, all the people and planets and whatever, black holes, things, okay? That's 5%. And about 4% of that is gas. And that's mostly hydrogen. So most of the visible matter, the vast majority of visible matter, is this gas, and it's mostly way out here between the galaxies, because if you look, there's a lot of space between the galaxies. And this gas, I'm not sure how they call it hot, because there's like, was it like a couple atoms per cubic meter? It's like the least dense part of the universe, this intergalactic medium, IGM, but it's very I guess it's very, very hot in that it gives off like X-rays. So I couldn't just talk about all these beautiful nebulae and all these awesome star forming regions that we have in our galaxy and being like, wow, look at all this gas that's out there, without being like, well, you know, actually the universe as a whole is pretty gassy. And a lot of it's like out beyond the galaxies, like between galaxies. So yeah, if you think our atmosphere has a lot of gas, or that, you know, these nebulae 100 light years across, like, yeah, that seems like a lot of gas. No, it's mostly out between the galaxies. You have to leave the galaxy, which, you know, good luck with that. We've barely left the solar system. So that's kind of what I wanted to talk about this week. I was pretty excited just to share some pretty views. I hope people get a chance to see the Perseids. So remember that peak is coming up in the next week. So if you didn't get a chance to tune in last week, you can check out the video. It talks a little bit about the Perseids and why we have them and how to view them and all that good stuff. But while you're out there, if you have a pair of binoculars, you know, while you're looking up, If you get tired of waiting for a meteor to come by, maybe just scan a little bit of the Milky Way with your binoculars if you have them, and see if you see any of those fuzzy spots along the plane of the galaxy. But then put your binoculars down again, because if you keep binoculars to your face, you're not going to see very many meteors, if any at all. So sorry about the late start. Thanks everyone so much for still tuning in. Let me throw up roll credits. And yeah, so again, I'm Irene Pease with the Amateur Astronomers Association. You can find out more about the fun things we're doing at AAA at AAA.org. You can follow us on all the social media things at AAADOTORG. And if you're interested in the graphics that we were using, go ahead and check out OpenSpace, openspaceproject.com, and or Stellarium, which you can find at stellarium.org. So thanks again, everyone, for tuning in, and have a safe night. And yeah, thanks again for tuning into your Thursday evening dose of astronomy.